Hi students. My video earlier, it talked about how to convert logarithms to exponents and exponents to logarithms. So now we're going to move on to how to graph log functions. So my number one on my graphing logarithms, it is actually the parent function of log base 2 of x. So we're going to just see how we can plug into our calculator and find some values. And I'm gonna start with -1 because I want to show you first that there is no value of log -1. So we have to think about how we're going to do this, and so we're going to do log of x over log of 2 because it's a change of base form. So I do log of -1 divided by log of 2. And you can see that it says a non-real answer. So there is no answer for here. And so you can do the same thing and look at log of 0 divided by log of 2. And that gives us the same thing. It's a domain error. So you don't get anything. But let's see if we get anything for 0.01. Just because I think that we're going to see a difference here. So we're going to clear that, and log 0.01 divided by log of 2. And you're going to see that it's -6.64. So it looks like there may be an asymptote at right here at x is equal to 0. So let's see what we have when we plug in log of 1 divided by log of 2. It's going to be 0, and then we'll plug in log of 2 divided by log of 2. It's going to be 1, and then we'll do log of 3 divided by log of 2, 1.6, and then log of 4 divided by log of 2 is 2, and you can keep on going, but I'll stop at log of 5 divided by log of 2. 2.3. So using these values to graph, we can use our graph, and we know that it looks like there's an asymptote at x is equal to 0. So I go down here and close to 0, it's down here. And then as I get to 1, it's going to actually cross the x-axis. And 2 is going to be at 1. And then 4 is going to be at 2. And then 5 is going to be at 2.3. So my graph is going to look like this. So if you notice, though, it kind of looks like when we were graphing exponential functions, but it says it's a little bit different because exponential functions went like this. And so you could see that your domain, you had a graph for all of your domain, for every single x value. But here, our domain stops at our asymptote. So in this case, my domain is any x value greater than 0. And my range, it looks like, is going to be all real numbers. Numbers, which looks like that. My x-intercept is going to be 1, 0. And my y-intercept, there's none. And you can see my graph is increasing as my values of x are increasing. My asymptote is going to be at x is equal to 0. And my end behavior, as x approaches 0, y, or f of x, approaches -infinity. And as x approaches positive infinity, f of x approaches positive infinity. So that's how you're going to graph it. Now if you look at this one right here, number 2, it looks like the same parent function. But in this case, everything's going to be moved up 2 because this is my shift up or down. So we're going to go up 2. So instead of being at -6.63, it's going to be at right here. It's still going to have my asymptote. And instead of being at 1, 0, it's going to be at 1, 2. And so it's going to continue on. And so that would be here. And you can plug them into your graph but your graph is going to look something like this. And it's just shifted up 2. So my domain is exactly the same. My range is all real numbers. My x-intercept is a little bit different. It's going to be somewhere close to 0, and you can plug that into your calculator and figure it out. So it would be somewhere like 0. I think it's 260. That's what it would look like. You can look on your graph, or you can actually look on your graphing calculator and find the answer for that. It's still increasing. There's an x equals 0 is your asymptote, and then the same thing applies here. As x approaches 0, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. When we get over here, it's the same parent function because we're doing log base 2. In this case, it is shifted to the left 2. So all of your values are going to be shifted to the left 2. So I'm going to have an asymptote at x is equal to negative 2 because it was before. So my graph is going to look something like this. Okay, and your domain is going to be all values of x that are greater than negative 2. Range, all real numbers. My x-intercept is going to end up being negative 1, 0. My y-intercept, and you can look at your graph, I do believe is going to be 0, 1. It is increasing again. There's an asymptote as x is equal to negative 2. End behavior as x approaches negative 2, f of x approaches negative infinity, f of x approaches positive infinity, f of x approaches positive infinity. So that's kind of how it works. And here you have a parent graph of log base 2. It's going to be shifted to the right, right 1, down 3. And you can do your graph or your table to plug in numbers for your graph, kind of same as before. But in this case, you know your asymptote is going to be at x is equal to 1, and my domain is going to be x is greater than 1, and my range is going to be all real numbers again. Again, it's going to increase. You can find the x and the y-intercept from the graph. Same type of situation. So that kind of covers graphing. It's pretty straightforward. Make your table, do your graph, look at the parent function, see the shifts that are going on. If you look at number 5, it's going to be shifted to the left 1, down 4. If you look at number 6, it's going to be shifted to the left 1, up 1. Here, 7 shifted to the left 2, up 1, and 8 shifted down 2, up 1. Hopefully that'll help you with graphing logarithms.